Section number 30. Comparing fractions. Comparing fractions. Okay, so now we should know two symbols. This symbol that I just wrote, that symbol means less than. This symbol means greater than. Possibly a lot of times I'll write LT and GT, less than, greater than. So, you would read this as A is greater than B. Maybe I should say is. A is greater than B. You have this. You would read this as A is less than B. I like to think of this as an arrowhead. Is the smaller end, the one with the point, points to the smaller number. Even this way, it points to the smaller number. 2 and 7. 2 is smaller. The arrow goes to 2. This happens to be less than, but notice I knew which way the arrow went without even knowing the symbol. 2 is less than 7. 13, 4. The arrow points to the smaller number. 13 is greater than 4. But notice I knew what symbol to put without even knowing the name of the symbol. Without even knowing the name of the symbol. 0 and 11. 0 is smaller. The arrow points to 0. 0 is less than 11. Bottom corner, right corner. 13 and 11. 11 is smaller. The arrowhead goes to 11. 13 is greater than 11. 4 and 9. 4 is smaller. Put the arrow towards the 4. 4 is less than 9. The arrow points to the smaller number. So, put in the correct symbol. 100, 2, 3, 75, 82, 86, 11, 13, 8, 13, 2/3, 4/3. Well, between the first one, between 100 and 2, 2 is smaller. The arrow goes to 2. Between 3 and 75, 3 is smaller. Between 82 and 86, 82 is smaller. Point to 82. Between 11 and 13, 13 is smaller. The arrow goes to the 13. Between 18 and 13, 13 is smaller. The arrowhead goes to the 13. It points to the 13. Think of these as pointers. They're pointing somewhere. 2/3, 4/3. You take the test that has 3 problems. You got 2 points out of 3 problems. I'd rather get 4 points out of 3 problems. 2/3 is smaller. Oh, arrow goes to the 2/3. It goes to the smaller number. It goes to the smaller number. 8, 1/3. 1/3 isn't even 1 yet. It's less than 1. 8 It's more than 1. Oh, 1/3 is smaller. Put the arrowhead towards the smaller number. You don't even have to know what those symbols mean. Less than, greater than. So I say you don't have to know what it means. What this would mean, so you don't know this is less than or greater than. It's pointing to 3. This means 3 is smaller than 8. I mean, let's suppose you don't even know what they are, because you know 3 is smaller than 8. What does this mean? A, since it's pointing to A is smaller. A is smaller than B. If you see this, it's pointing to B. B is smaller. B is smaller than A. B is smaller than A. That's what this says. B is smaller than A. You know what? There's one reason why B is smaller than A. And that's because A is bigger than B. If you want to say A first, and that's how you can figure out that it means greater than or less than. Instead of saying smaller than, I can say less than. Since the arrow's pointing to A, we know A is less than B. And you really want to start off with A, and I did. The arrowhead is pointing to B. This says B is less than A. But I want to start off saying A first. Well, if B is less than A, it must be because A is greater than B. That's the greater than symbol. A is greater than B. A is less than B. Okay, so if you forget, as long as you remember the arrow goes to the smaller number. As long as you remember the arrow goes to the smaller number. Since it's going to Y, we know that Y is less than X. But you're supposed to read X first, and then this symbol, and then Y. I kind of did that backwards. I said Y first. Well, there's only one reason why Y is less than X. And that's because X is greater than Y. X is greater than Y. Oh, that's the greater than symbol. Now I remember. You can forget that anytime you want. But nonetheless, the arrow points to the smaller value. So now we want to play this game. Arrange the numbers from smallest to largest. From smallest to the largest. The numbers are 2 over 7, 6 over 7, or 4 over 7. If you have a test that has 7 questions, or you're the teacher and you give a test that has 7 questions, and 3 students take the test, one gets 2 out of the 7, one gets 6 out of the 7, one gets 4 out of the 7. We want to go from smallest to largest. Well, I happen to know all the denominators are 7. The one who got the least number right got the lowest grade. 2 out of 7 is the smallest. 4 out of the 7 is the middle grade. And 6 out of the 7, that's the largest grade. If the denominators are the same, you just arrange the numerators, in this case, from smallest to largest. Suppose you have, so that's one answer. Here's the list of numbers. Here's the list from smallest to largest. Now I'm giving you a list of numbers. You can think that the test has 15 questions, or you can think you buy a pizza, there's a pizzeria who cuts the pies into 15 equal pieces. I'm probably wrong, but imagine it's 15. Okay, so from smallest to large. Well, We know the three numbers all are over 15. The smallest one is 4 out of 15. Somebody only had 4 slices. The next hungriest person, or the next least hungriest person, had 8. The hungriest person, or the person that had the most, had 12. I'd rather get 12 questions right out of 15 than 8 questions right out of 15. I at least would like to get 4 out of 15. As my teacher said, these are the 3 grades, 8 out of 15, 4 out of 15, 12 out of 15. Of course I'm going to hope I got 12 out of 15, because that's the largest. Teacher hands back that test, and teacher didn't hand it to you. Then you say, boy, oh boy, I hope I got 8 out of 15, because that's the next largest grade. And hopefully you didn't get the 4 out of 15. If the denominators are the same, the smallest fraction has the smallest numerator, the largest fraction has the largest. That is, just arrange the numerators in the order they tell you. Smallest the largest, largest the smallest. Whatever they say, you do. Now, if somebody said insert the correct symbol here. Insert the correct symbol in between. Well, both students got 2 questions right. The first student got 2 questions right out of 7. The next student got 2 questions right out of 5. Now, if you take a test and you're going to only have 2 questions, you're only going to get 2 right. Do you want to get 2 right out of 1,000? Or do you want to get 2 right out of 3? You have 2 pieces of candy and you're hungry. Who gets the bigger pieces? You have 2 pieces of candy and you split them, you divide them, you share them among 7 people, or you share them among 5 people. Okay? If somebody comes home for dinner tonight with 2 pizza pies and you're really hungry, would you rather there be 7 people sitting at the table or 5 people sitting at the table? Do you want to share the 2 pizza pies with 5 people or 7? Okay? If you share it with 5, you get bigger pieces than when you share it with 7. 2 over 7 is smaller. 2 over 7 is smaller. So if the numerators are the same, you want the denominators to be smaller to be large. The larger the denominator, the smaller the fraction. I'd rather have 2 slices out of 3 as compared to 2 slices out of 1,000. Here's the 3. You get 2 out of 3. I'm not going to do 1,000, of course. But 1,000, boy, oh boy, these slices are going to be small. They're going to be really small. You're getting just 2 right out of 1,000, or 2 slices out of 1,000. This person, there was 3 questions on their test. They got 2 right. Or 3 pies, 3 slices in their pies, and they had 2 of them. This person, they have a long test, 1,000 questions, and they only got 2 right. This one and this one. Or they bought a pie that was cut into 1,000 pieces, and they just ate 2 of them. Of course, the 2 out of the 1,000 is going to be smaller. And I put the arrow to it. The 2 over 7 is smaller, because I'm dividing the 2 into 7 pieces as opposed to 5. The numerators are the same. The smaller fraction has bigger denominator. So I give you 13 over 8 and 13 over 7. The one with the bigger denominator is smaller. Of course, again, this is if the denominators are equal. Excuse me, the numerators are equal. If they're equal, you want to split them among, or share them among, the smallest number of people to get the largest. Okay, smallest to largest. We have 12 over 8, 12 over 6, and 12 over 14. In this case, we know the numerators. They're not changing. The denominator is changing. The one, now we want the smallest first. So we put the largest denominator first. Now that one's gone. Now we put the largest remaining denominator. And then process of elimination, 12 over 6. There it is. Okay, this is the smallest, that's the middle number, that's the largest. Smallest to largest. Six over 22, 6 over 10, 6 over 8, 6 over 12, and one more, 6 over 18. We want to go from smallest to largest. So, the smallest one has the largest denominator. There are 5 numbers, they all have 6 on the top. The largest denominator, the next largest denominator is 18, and then 12, and then 10, and then 8. Of course, this is very, very simple. You can do 50 of these problems and get them all right, and then when the test comes, you don't know how to do it. Why? Because you didn't memorize. If the numerators are the same, I'm given a number of fractions, and all the numerators are the same, then the one with the largest denominator is the smallest. And then of the remaining ones, the one with the largest denominator is the next smallest, and so on. That is, just arrange the denominators from largest to smallest. And then you will have arranged numbers from smallest to largest. If they ask you to arrange numbers from largest to smallest, well then, you do it in reverse order. They say largest and the numerators are all the same, you put the smallest denominator. You put the denominators in increasing order. Smallest up to the largest. And there it is. There's your ordering. They go from largest to smallest. This is the largest number of the remaining 4 numbers. That's the next largest of the remaining numbers. That's the largest of the remaining 2. That's the largest. And of the remaining 1, that's the largest, or you can say it's the smallest. You need to go home and study that. The numerators are the same, and you want to go largest to smallest, you arrange the denominators from smallest to largest. You want to say that's complicated? Fine. But nonetheless, you can memorize it. Now, suppose they give you this, 7 over 6, what's a good next number? 2 over 5, and 4 over 7. And if they go from smallest to largest. Now, you should be able to recognize a half. You should be able to recognize a half. If I want all these fractions to equal a half, if I put 8 on the bottom, I should have half on top. You have 13 on the bottom, half of it should be on top. 6.5 divided by 13 is a half. You have $6.50 and you share them between 13 people, they each get half a dollar. If you have 9 on the bottom, you have 4.5 on top. If you have 10 on the bottom, you should have half on top. If you have 3 on the top, you should have double on the bottom. If you double 6.5, you get 13. If you double 1, you get 2. These fractions all equal a half. Now, how do you tell if a fraction is more than 1? If the numerator is bigger than the denominator. This here is the only fraction more than 1. That tells me it's the largest. Now, 2.5 divided by 5, that's a half. Well, 2 over 5 is smaller. You only had 2 slices out of 5. Here you had 2.5 slices out of 5. 2 over 5 is smaller than a half. But you know what? When it comes to 7 in the bottom, 3.5 over 7 is a half. 4 out of 7 is bigger. This number is less than a half. This number is more than a half. 2 over 5, 4 over 7. 2/5 is smaller than 4 over 7. 2/5 is less than a half. This is more than a half, or less than 1. And this is more than 1. I would know a half like I know my name. The numerator should be half of the denominator. So if I give you this, and I give you this, I say arrange from smallest to largest. Well, when I think of 7, I want to get a half. 3.5 should be on top. So this number is more than a half because it's 4 out of 7. 4 is bigger than 3.5. That is 3.5 out of 7. Why, that's a half. 4 out of 7 is bigger. 4 out of 7 is bigger than a half. But now when it comes to 9, 4.5 out of 9 is a half. You only have 4 over 9. This number is 4 over 9. That's less than a half. Smallest to largest. Also, since the numerators were the same, to go smallest to largest, you put the largest denominator first. That didn't really mean for the two tops to be the same. It just worked out that way. But if you look at a half, that's pretty good. You run into trouble if more than one number is either less than a half or more than a half. If you have 3 over 8 and 14 over 25 and 11 over 3. First I would say this number is more than 1. 3 over 8. Well, we know that 4 over 8 is a half. So 3 over 8 is less than a half. Now this number is less than 1. Now, when it comes to 25, half of it is 12 and a half. 12 and a half out of 25 is a half. You have more than 12 and a half. You have 14. This is bigger than a half. So if I say go from largest to smallest, well, the largest number is a number that's bigger than 1. The next number is bigger than a half, but less than 1. And the next number is smaller than a half. Here's a half. You have 3 over 8 to the left of a half, and here's 1. And you have 14 over 15 being more than a half, but less than 1. And then you have 11 over 3, which is actually bigger than 3. Well, that's the largest, that's the middle, and that's the smallest. Given two numbers, the one on a number line. Even if some of the numbers are negative, if this is A and this is B, the number to the left is smaller, always. Doesn't matter if they're both negative or both positive or one negative and one positive, the number to the left is always smaller. Knowing your half is not a bad way of doing this. You should know half of numbers. Half of 7 is 3.5, half of 8 is 4, half of 9 is 4.5. You should know that. Okay, now I'll give you a rule that will probably make you happy. If A over B is less than C over D, then AD should be less than BC. AD should be less than CD. If A over B is less than C over D, then I meant to say greater than, I'll change that. Then AD should be, what happened? Oh, yeah. I think I said it right, I just wrote it wrong. AD is less than BC, is bigger than BC. That is, you cross multiply. Whatever symbol goes here should go there. If greater than goes here, then it goes here. For example, 2/3 is what symbol? 4/7. What you do is you multiply. 2 times 7 is 14. Put it to the left. 3 times 4 is 12. When you multiply two numbers, the top number, that determines what side you go. When you multiply the 7 by the 2, the 2's on the left side, it's in top. On the left, you put it on the left. 3 times 4, look at the top number. It's on the right, I put it there. Between 14 and 12, that's the symbol. Notice I pointed to the smaller number. Greater than. I multiply 2 by 7 to get to 14, and 3 times 4 to get to 12. 1/3 and 7/8. Well, 1.5 over 3 is a half. That's less than a half. 1 is less than 1.5, so that fraction is less than a half. 4 out of 8 is a half. That's 7 out of 8. It's bigger than a half. Okay, but we want to know what, we know what the answer is, but let's do the cross multiplication. You multiply the 8 by the 1 and you get 8. The 3 by the 7, you get 21. Between 8 and 21, 8 is smaller, so the symbol goes that way. That's the same symbol that goes up there. You cross multiply, you can figure this out. So let's do one where I give you 3 numbers, and I want to know which one is, I want it to go from smallest to largest. And we can do the cross multiplication way. We have 2/3, 7 over 8, and 1/4. And you want to go smaller to larger. Well, let's compare these two. And here is going to be a number line. Let's compare those two. What symbol goes in between here? Well, if you multiply the 8 by the 2, you get 16. Since the 2's on the top, and it's to the left, that's where I put the 16. Now you multiply the 3 by the 7, you get 21. Since the 7's on the top and it's to the right, I put 21 to the right. And the symbol goes this way. That is, here is 2/3, and here is 7 over 8. That is 2/3 is smaller than 7 over 8. Now when it comes to a quarter, it can either go to the left of 2/3, it can go in between the two numbers, or it can be bigger than 7 over 8. So now we have to decide where it's going to be. Well, let's compare it to 2/3. 1/4 and 2/3. What's the symbol? 3 times 1 is 3. 4 times 2 is 8. 3 is less than 8. So a quarter is less than 2/3. Okay, so a quarter goes here. And there's the order. The quarter goes here. There's the order. 1/4, and then 2/3, and then 7 over 8. Hopefully, yep, smallest to larger. And there's the answer. Now, let's just modify this problem a little. Let's just modify this problem with one thing. The last number is not 1/4. It's 3/4. Suppose the last number is 3/4. Okay. So we concluded that 2/3 is smaller than 7 over 8. Now the 3/4, assuming it doesn't equal one of the first two numbers, either it's below 2/3, or it's in between 2/3 and 7 over 8, or it's bigger than 7 over 8. It's one of those three. Well, let's compare the 2/3 and the 3/4. 4 times 2 is 8. 3 times 3 is 9. 8 is smaller. It goes this way. That is, 3/4 is bigger than 2/3. So it won't go here. If you're bigger than 2/3, well then you're either bigger than 2/3 but less than 7 over 8, or you're bigger than 7 over 8. So, are we bigger than or smaller than 7 over 8? 3/4, 7 over 8, which is bigger? 8 times 3 is 24. 4 times 7 is 28. 24 is smaller. 3/4 is smaller than 28. Okay, so it goes in here. And that's the order. This number, smallest, middle, largest. That's smallest to largest. If they would have asked instead, largest to smallest, well then I would just reverse the order. I would say 7 over 8 is the largest, 3 over 4 is the next largest, and 2/3 is the smallest. I would just read these three numbers in opposite order. Right to left instead of left to right. Now, another way of finding out from smallest to largest, that is the arranging numbers, so we want to go from smallest to largest. If the denominators were all the same, then we just arrange the numerators. In other words, if you were given 7 over 8, 4 over 8, and 19 over 8, well, from smallest to largest, well, we know everything's over 8. We would put down the smallest numerator, the next smallest numerator, and the largest numerator, and we'd be done. So what we can do is find the least common multiple of these three numbers. The 2 table, the 7 table, and the 6 times table. Now, to be in all three, for a number to be in all three, it has to be on the 7 table and the 6 table. And the 2 table, but it has to be on the 7 and the 6 table. But everything on the 6 table is on the 2 table. 6 is on the 2 table, 12 is on the 2 table, 18, 24, 30, 36, 42, 49. Every even number is on the 2 table. And the numbers I just wrote, with the exception of the last one, which is wrong, every number I just wrote is even. Since 2 goes into 8, it will be on there. Since 2 goes into 6, it'll be on there. You know what? If I also had 3, every number, since 3 goes into 6, every number on the 6 table is on the 3 table. 6, 12, 18, 24, 30. You know what? Since 3 goes into 6 2 times, it's every other number. It's not this one, it's this one. It's not this number, that's on the 6 table. Not this, that, yes. Not this, yes, that. Okay. So we just really have to find the least common multiple of 6 and 7. LCM is 6 and 7. If you don't see that, list the 2 table. 7, 14, 21, 28, 35, 42. I'll stop right there. Eventually, on the 2 table, you'll get to 40 and then 42. 42 is on all 3 numbers. So, I want to rewrite these 3 numbers with 42 on the bottom. If I multiply by 21 over 21, I get 21 over 42. If I multiply by 6 over 6, I get 24 over 42. 24 over 42. If I multiply by 7 over 7, I get 14 over 42. Smallest to largest, well, they're all over 42 now. Smallest numerator of the 2 remaining ones, that's the smaller numerator. That's the largest. And 14 over 42 came from 2 over 6. 21 over 42 came from a half. And 24 over 42 came from 4 over 7. There it is. There's the ordering from smallest to largest. Get the denominators to be the same, and then arrange the numerators. This method works for every one of the columns you just did. Possibly you would have preferred me only to show this one method, which is fine. You have 2 over 3 and 2 over 5 and 2 over 15 and 2 over 10. Well, to go smallest to largest, since the numerators are all the same, I told you to reverse the order for the bottoms. Write the largest to the smallest first. 15 is the largest, 10 is the next largest, 3 is the smallest. That's the ordering. That's the ordering. And we're done. Or you can say the LCM is 30. 2 over 3, I'll multiply by 10 over 10. And I get 20 over 30. For the 2 over 15, I will multiply by 2 over 2. I get 4 over 30. For the 2 over 10, I will multiply by 3 over 3. And I'll get 6 over 30. So, this is the smallest, because it's the smallest enough numerator. This is the middle number, and this is the largest number. That is, the smallest number is 2 over 15. The middle number is 2 over 10, which I have. And the largest number is 2/3. It was a lot more work, in my opinion. A lot more. I had to get common denominators of 3 different fractions. First, I had to figure out what the common denominator was. The way I did it was, the numerators are the same, I want to go smallest to largest. I put the largest denominator first, the next one second, and the smallest one last. And there's my answer. Of course, what I just did here, right here, was a lot quicker. For you as a student, have to memorize, have to see that if the numerators are all the same, then if you want to go from largest to smallest, the denominator should be the opposite. They should be smallest to largest. If I want to arrange these numbers from largest to smallest, and they're all the numerators are 2, largest to smallest, I think the other way. I put down the smallest denominator, 3, the next smallest one, the least smallest one, and there's my order. Okay, that finishes the section on comparing fractions. Good luck with it.